Hello everyone, welcome to KT Simicon self-based learning modules. In this particular session, we are going to discuss about BCD coding scheme. So before that, let me share my screen. Now, in the case of your binary coded BCD code or 8421 code, first of all, let us try to understand about this particular coding. So the binary coded decimal is a type of binary code used to represent a given decimal number in an equivalent binary form. So the BCD equivalent of a decimal number is written by replacing each decimal digit in its integral and fractional parts with its 4-bit binary. Now, what do I mean here? Let's say if I want to write down the BCD equivalent of a decimal digit 0. Now, how I'm going to write it down is simply representing this 0 with 4-bit binary equivalent. That is nothing but 0000. That's it. This is nothing but my BCD code for 0. Now, if let's say if I want to write down the BCD code for decimal digit 1, now how to write this 0001? Let's say if I want to write it for 2, that is nothing but 0010, and for 3, it is nothing but simply 0011. And coming to 4 is nothing but 0100, and 5 is nothing but 0101. 6 is nothing but 0110, 7 is nothing but 0111, and coming to 8, it is nothing but 1000. Okay. Now, let's say if I want to represent 9 in my BCD representation, it is nothing but 1001. Now, if I want to represent 10 in BCD format, then it is not 1010. No, I cannot represent 10 in BCD format as 1010. What is the rule is I need to represent each and every digit with its 4-bit binary equivalent. That means 10 is nothing but 0001 followed by 4 zeros. So this is the BCD equivalent of the decimal digit 10. Okay. So I'm not going to have a code like 1010. And for representing my 11, I cannot simply use 1011. No, I cannot use this. So what should I do? I should write down 0001 followed by 0001. I don't have a code like 101. And for representing my 12, I cannot simply write 1100. No, this is invalid. So I should write down 0001 followed by 0010. Okay. And if I want to represent 13, how to represent this 13? I cannot write down 1101. No, this is an invalid representation. I should write down 0001 followed by 0011. And let's say if I want to represent 14, then I cannot simply write down like this. This is an invalid representation. I should write down 0001 followed by 0100. So this is how we are going to represent our BCD coded decimal format. And if you can observe, we don't have the codes 1010, 1011, 1100, 1101, 1110, and 4 ones in our BCD representation. So these are nothing but our 6 invalid codes in our BCD representation. We don't have these codes in our BCD representation. Now, let's say if I want to add two BCD numbers, let's say 1000 and 0001. If I want to perform BCD addition between these two numbers, then how I'm going to perform BCD addition between these two numbers is simple again. 0 plus 1 is 1, 0, 0, 1, 0, 0, 1. This is how I'm going to perform BCD addition between two BCD numbers. Let's say if I'm going to have two BCD numbers as 1001 and 1001. Now, what is the answer we are going to get if we add these two? 1 plus 1 is 0, 1, 1, 0, 1, 0, 1, 0. But 1010 is an invalid BCD code. This is an invalid BCD code. Now, what to do if we are going to get any invalid to add 0110? That is, we are going to add 6 to an invalid BCD code valid BCD code. Okay, so that is our answer will be 0, 110 is 1, 110 is 1, 110 is 1. And if we are getting any carry, we are going to discard it. So this is how we are going to perform our BCD addition between two BCD numbers. And remember, if we are going to get any invalid code, just we are going to add +6 to make that particular code as a valid code. So that's about your BCD coded decimal and BCD addition. And in our next session, we are going to see excess 3 code. Thank you.